He didn't believe that democracy would work unless he was a dictator for life. He built himself a big brick palace on the land, demolished what was left of the abbey and built himself a brick palace. When he died, the monarchy took it back. The monarchy was restored. They demolished his brick palace and slowly built some nice houses. But the city boomed, London boomed, and those houses were no longer for noble people, but became slums. Now the next two people you see are William Morris. So William Morris put a printing press on the same road that we're on, and he called it the 20th century press. This is the 1900s. And he had a writer for him called Karl Marx, and the picture of that building you see is William Morris's original printing press. It is now the Karl Marx Memorial Library. Lenin wrote, we used the printing presses to write his language paper there, Russian language paper there, and even to this day, the Labour Party in England will start its May Day march from that location. So our building is directly behind the one you can see with the crowd in front of it. If you go to the next slide. So that's a lot of history, a lot of interesting social history of change, dramatic change to the country with the Norman invasion, Henry VIII, Oliver Cromwell, slum clearances, etc. So we wondered where on earth are we going to start with this. Let's be slightly literal. We'll be on a site that is actually occupied by timber structures, not stone structures, because we're not on the formal abbey buildings, but they're stables, etc. So why not allude to the external skeleton like a timber frame, except it was a bronze finished skeleton. This was very much liked by some of the planning officers, but absolutely not by some of the conservation officers who felt that brick or stone should be the predominant material. We're not very proud about what material we use. We thought we'd take the challenge. Now, as most of you know, stone is built, most stone buildings are built using this technology. This is, there's a superstructure behind in that detail, concrete in this case, insulation with a vapor barrier, a gap, and the stone is cladding as a rain screen. Quite complex, and I've seen people build it in London. There'll be a team of 4 people working on one column for 1 week to actually finish it off. Seems, I mean, we all accept it, it's conventional wisdom, this is the way you build today. As architects, as I described earlier, we're asking ourselves, where on earth are we coming from, how do we start? Our interest is in building in materials that can do the same job as holding up the building as what you see ultimately. Not every project has to follow that rule, but as close as possible. Stone. So we asked ourselves the question, well, does stone have to be used like this? Is there no alternative? Can we not build as it was used traditionally? If you go to the next slide. Yeah, so we were working on a private house project with French stonemasons. So in England, our stonemasons are only educated to work for decoration. They're not educated to use stone for structural purposes. So we had to use French stonemasons for a structural staircase. So one of these old staircases that looks like it's being held up by air, but it's actually an engineering technology that was only rediscovered in England in the late 20th century. It's a sort of reciprocal, part cantilevered, part reciprocal structural flow. In this case, it was travertine. So that staircase effectively holds itself up from one landing to the other and is only keyed in at one point in the wall. So we asked those French stonemasons, we've got a building to do now, not just a staircase. Is that possible? They said, of course it's possible. In France, after the war, there was a French architect, Fernand Poulon, who demonstrated to the French government that it was cheaper and quicker to build in stone than it was in concrete or steel. Now, wasn't the fashion after the war to build in stone, because concrete and steel frames were part of that progressive tradition, if you like. So his lessons were pretty much ignored ultimately. However, we thought, let's see if it's still possible. So the important lesson here of the French stonemasons are telling us is, you see this staircase looks like, well, there are no columns holding it up, it's complete stone, there's no internal steel structure, this is not clad in any way. So it's all stone that sits against the wall and takes mutual rest from another piece of stone. The important thing here is, since the Middle Ages, they've been teaching in France the idea of what's called stereotomy. And that's the method that stone is cut to be able to rest its load on the next stone and the next stone and the next stone. So it's not about just drawing stone and understanding how you do the perspective of stone, but it's understanding that if I use this particular type of stone and I need to span this distance, how do I cut the stone to take the load path to where it should go? Go on to the next slide. Our first trip then was to a quarry, because as architects we'd never used stone for structural purposes. We asked if we could go and visit the quarry to investigate what the stone looks like, its texture, its colour. If you go on to the next slide. Yeah. And what we found was, onto the next slide as well, what we found is that stone is actually now, our stonemasons tell us, has become much cheaper to extract in the last 15 or so years, because industrial diamonds have become incredibly much cheaper. So what's going on here is vertical cuts are being made using a cable with industrial diamonds on it. And occasionally you still have to use some hand tooling where it hasn't broken across its sedimentary layer. Go to the next slide. So principally in the quarry there are three types of finishes that result simply from extracting the stone. One is the saw cut of this cable with the industrial diamonds. The other one is either machine or hand drilling to subdivide the large blocks into the master blocks, the smaller master blocks that go onto the back of the trucks to the stonemason's yard. And then another layer is the natural sedimentary layer. Go on to the next slide. In that sedimentary layer you'll have, because it's a sedimentary stone, you'll occasionally get fossils, ammonite shells and quartz crystals. This is a sample we had made of how a column, two beams and another column fit together, and behind which a metal boss is then simply grouted. So you put it in place with mortar to keep it in place, and nothing else. Now, you'll notice the stone there is cleanly cut. And that's because the quarry master and the stonemason, well, as architects, you always want, all architects want clean cut stone, and then if you want something added to it, the stonemason will carve it in. The stonemason told us, I can give you natural. We said, well, why do you want to give us natural? Well, because all the stone gets delivered to me like this. We asked, well, what about all the fossils in the quarry, and the natural sedimentary layer, the ammonite shells, the coral, etc. And he said, well, actually, that normally gets crushed as aggregate and then used as road aggregate before it gets tarmacked over. And we said, well, it's completely perverse that you're crushing, getting rid of this, and then carving in artificially a natural finish. Can we keep the natural finish? So the decisions went in three steps. The first one is, can we build in stones? Is it economically viable to build in stone? The stonemasons came back with a price, which, as our previous speaker was explaining, turned out to be 25%, so a quarter of the price, if we built our building out of steel or concrete, and then did that cladding that I showed you earlier, that cladding with the insulation, etc. Well, we had to have our poker faces on because we thought, well, this is crazy. Even if he doubles the price, it'll still be half the price of the other one. The next decision is, engineering-wise, will it stand up? Now, we're not in a seismic area in the UK, but we have to deal with what's called progressive collapse. So if you take one column away, will the other columns drop after it? The way to deal with that is to oversize your column. columns. So to make sure that no vehicle, no internal gas explosion can ever remove that stone. So you either oversize the columns or you reinforce the edge of your slab to be able to deflect, deform without collapsing, with enough time to then prop before you get a new column in. The next decision is, how do you finish that stone? Well, as I described, the answer became pretty easy. Why not just leave the natural material as it is? In Japan, for the last 700 years, they've celebrated the idea that whether it's stone or timber or any other material, the making or even of clay, the errors in that, the naturalness of that as a spirit, why not celebrate it? And in the UK, it was harder to persuade people that natural is actually got some beauty in it. It's not shockingly ugly, which is the initial reaction, I think, when you present people fossils as a finish. Go on to the next slide. So this is the detail. So we're interested in keeping those details as simple as possible. What you see, you can see some concrete there, which is the floor slab. Above that is insulation, and the finish on this building, they wanted polished concrete as a floor slab, not timber or tiles, ceramic tiles. We actually are building another structure exactly the same, but now using timber as a floor slab instead of concrete, cross-laminated timber. But you can see there, the stone has got a pocket cut into it, in which one metal boss sits. The other metal boss is already pre-cast into the concrete, and then between them you bolt it together, and you have a solid nylon bar, which is the thermal break from between the inside and the outside. And then a standard inexpensive curtain wall that runs down the entire facade. Go to the next slide. So that's the floor slabs on temporary props, like any normal concrete structure, but there's no columns there, no concrete columns. So you keep the temporary props there in position, and it takes one day to put one row of columns and one row of beams. So the next day is reasonably fast, much faster than putting all those cladding panels on. Yeah. So you can see that they're simply lifted into place, and then the metal bosses put in. You can see in that slide on the bottom left-hand corner one of the cuts in the back of the beam where the metal boss will go in. You can go to the next slide. So that's slowly, day by day, the structure. That's at ground level, so we actually have two buildings next to us, which are lower than us, but so at ground level, the exoskeleton, as it were, creates a colonnade on one side, and then the facade on the main street. So that's a typical upper floor. So as the building gets higher and higher, the size of the stones diminish depending on the load requirement set out by the engineer. That's the final rendering of it, drawing of it. And that's it in its context. So the context that we're in, I talked about the William Morris library, and also about a great deal of demolition. So what you're actually looking at, everything else, is all 1970s and 1980s. Because there was a bit of a crisis immediately after the war. Everybody wanted to build concrete frames and modern buildings. And in this area, there was a little bit left, and we were about to demolish the church and what was left as archaeological grounds of the old abbey, when in the 70s there was suddenly a movement for conservation, and the immediate reaction was, okay, we're conserving the archaeological grounds, we're not going to demolish the church, but what do we build around this area? Well, fake, pretend Georgian, pretend buildings. So all these are actually steel frames with half a brick thick facades that are pretending to be Georgian, Victorian. And clearly that's not the challenge the challenge that we wanted to avoid, as it were. If you go on to the next. If you look carefully, some of those beams and columns change in in size, and that's how I describe the load path across the facade changing. Now, slightly counterintuitively, at the top they get bigger, and that's because there's no mass at the top to stop the wind from blowing the stone, so they have to get a little bit bigger to keep themselves in position with wind loading. But ultimately, from one master block, so one of those blocks I showed you in the quarry, you might initially, for the lower beams and columns, you might get maximum six of those. So if you divide that master block in 6, you know that you'll get a sedimentary layer, a drilled layer, and 2 saw cuts potentially. As you go up the building, you suddenly get more saw cuts because you can get more stones out of the